Now, while we're waiting for that to get started, that'll take a little while. What about filling your cylinders? As I said, most of you probably won't get this on the first shot, and that's fine. Because what does a bubble really do inside of this cylinder? It doesn't necessarily ruin your experiment. Your experiment can still work perfectly fine, but a bubble is a little bit of error. How big of an error, how devastating of an error is that bubble? Well, that depends. If you've got a 1 milliliter bubble and you collect 200 milliliters of volume, that's not much error. So as long as your bubbles are tiny, it's probably not a big deal. Do your best not to have bubbles, that makes it easiest, but if you've got a bubble or two, don't be too concerned. Now I'm seeing my aluminum start to react a little bit in that flask, so let's take a little look, shake it around a little bit. Something's starting to happen. Now one of the things that you may notice, I can almost guarantee you'll notice at some point, is this reaction doesn't just generate hydrogen gas, this reaction also generates heat. And you might be able to see a few bubbles starting to show up. And there it goes. It got through the aluminum oxide layer and it's starting to feel pretty warm. Hot gas takes up more volume than cold gas. We really want this gas to be room temperature. So as this heats up, first of all, make sure that the end of the tube is in gas and not in water. Second, go ahead and put your flask in your big tub of water and let it cool down, let it continue to react. You can take it out, swirl it around every once in a while, but you want to keep it in there so that it cools down. Now ideally we would keep track very closely of the temperature of the gas, and we would take that into account in our measurements, but as long as we have the gas at the same temperature for all of our experiments, we should be okay. Another thing, what about this water? Well, if we started out with really, really cold water in here at the beginning of our experiment, by the time we did all of our experiments, the water would change temperature. If we started out with really, really warm water in here, that would feel good to put your hands in, but again, by the time we got to the end, the temperature would change too much. So when you fill up your bin, try to fill it up with approximately room temperature water. It'll make it a little bit more comfortable for you to dig your hands in, and it'll make your experimental results a little bit more reliable. So let me swirl, give that a feel. That feels like it's cooled down to room temperature and it's stopped reacting. So now we can pull the tube out and we can actually pop the top on that. That's fine. Now what do we have? We've got our inverted graduated cylinder full of gas that we collected from our experiment. So keep in mind the scale is upside down. So I have just collected 324 milliliters of gas. So this combination gave me 324 milliliters of hydrogen gas. That's really the whole experiment. Now you're going to be doing a bunch of runs, but this is where we're starting. We're starting with one experiment so that we can see what goes on, so we can get things organized, get ourselves set up so that we can use a table, and ready to go. Now one other little tip. for this experiment, if you have bubbles, if you have bigger bubbles, we can actually get away with having bigger bubbles. And let me make a bigger bubble. Now you'll notice I'm not putting this stopper in my mouth. I'm making a ring with my fingers. There, I just made a bubble in that graduated cylinder. Now we could take an initial reading. Right now it looks like it's at 34 milliliters. If I use this to do my reaction, I could just take an initial reading and a final reading, subtract, and the difference would be how much gas I collected. That works fine. The only little problem that pops up with that is what happens when you put your tube in? My tube is fine. Keep an eye on the level of water. What if what if my tube gets above the level of the water? You end up draining everything out. So that's another place that bubbles can cause a little bit of trouble. I'm sure you'll get through any of those little problems without too much of an issue, but keep that in mind as you're setting things up. So after you do your first run, after you get that first volume, after you figure out how the experiment works, the next part of the experiment is up to you. You have to design an experiment, and designing a good scientific experiment usually means finding a variable and varying it. So think about the things that went into this reaction. Think about the different ways you can vary this experiment and write out a plan. That plan should include all of the next experiments you're going to do, not just the next one run. And before you go on with your plan, you need to get it approved by probably me or one of your lab assistants. So think about a plan, think about what you can vary, and let's see if we can figure out how to balance this chemical equation using experimental results, not using stuff that we learn in the classroom. Good luck on your experiment, and I'll see you on Thursday.